Okay, good afternoon all. In last lecture, we had discussed about the various types of earth pressure, that is active earth pressure, passive earth pressure, and earth pressure at rest. In the active earth pressure, what will happen? Wall move away from the backfill, and in the passive earth pressure, wall move towards the backfill, and in the rest condition, there is no movement of the wall. So depending upon, there are three kinds of the lateral earth pressure. There is the earth pressure at rest, earth pressure that is active earth pressure, passive earth pressure, denoted by letter sigma A for active earth, sigma P or PP for passive earth, and sigma 0 or P0 for rest condition. So next is the earth pressure coefficient. So we can consider depth h onto the backfill. There are two kinds of pressure. First one is so suppose we are considering one small element of the depth h onto the back side of the soil sample of soil mass. There are two pressure generally exist. First one, that is called as the vertical earth pressure, second is called as a horizontal earth pressure in any soil mass. Okay, suppose this is the soil mass. If we are considering any element, so there are two kinds of pressure generally exist. First is called as the horizontal, that is sigma h, and second is the vertical. So what is meant by the vertical earth pressure? So this pressure applied in vertical direction due to backfill lying above it. Okay, so this so suppose this is your retaining wall, and this is called as a backfill. Backfill. So this backfill will exert pressure in a vertical direction. Okay. The second pressure, that is horizontal earth pressure. So this soil will exert pressure into the wall in a horizontal direction due to this backfill. Okay, so this backfill will exert pressure in vertical direction as well as horizontal direction. Okay, so depending upon that, we can calculate the various coefficient, that is coefficient of active earth pressure at the rest, coefficient of active earth pressure, coefficient of earth pressure at rest. It is not active earth pressure, it is coefficient of pressure at rest, coefficient of active earth pressure and coefficient of passive earth pressure, that is K0 for coefficient of earth pressure at rest is the ratio of lateral earth pressure to the vertical pressure. So this K0 will be equal to sigma h, it is for lateral earth pressure, and sigma v is for vertical earth pressure due to the backfill. Then for similarly for active earth pressure, coefficient for active earth pressure we can denote it by letter Ka. So it is a ratio of lateral earth pressure, that is sigma h to sigma v. That is while solving problem we can consider it Ka as Ka equal to, it is 1 minus sine of phi, 1 minus sine of phi upon 1 plus sine of phi. Okay, so here we are giving a clear formula. So phi means the angle of internal friction, and for Kp, that is coefficient of the passive earth pressure, is the ratio of vertical lateral earth pressure to the vertical pressure, that is Kp equal to we can call as 1 plus sine of phi upon 1 minus sine of phi, or in short Kp equal to 1 upon Ka. Note that Kp equal to 1 upon Ka. Kp is nothing but 1 upon Ka. Okay. So next we consider we are studying the various derivations for the that is the active earth pressure, passive earth pressure, and at rest condition. Okay. So there are various theories we had already discussed, the Rankine's theory, then the Coulomb's theory, Kalman's theory, Rabin's theory were developed for solving the problems for this earth pressure. So now we are discussing the first concept, that is earth pressure at the rest, and we are going to solving some problem on that, and what is the derivation for the pressure, that we will discuss over here. So first of all, in the retaining wall, earth retain will be natural earth. We know that in the retaining wall, earth retain will be natural earth. Retaining earth means backfill material will be the natural earth. So this backfill material exists certain amount of lateral pressure onto the wall. If this wall is not rigid and does not move with the pressure exerted on wall, the soil behind the wall is in state of equilibrium. It means that if you are considering the wall, so this is a wall, and the material placed behind the wall, which is called the backfill, is a natural material. So this natural material or this soil will exert pressure onto the wall, and if this wall does not move because it is not rigid, and so the condition which is called as the elastic equilibrium condition is called elastic equilibrium or at rest condition, because there is no movement of the wall. So now we are considering one element, that is element E. Suppose this is our wall, and this is our retaining wall. Now we are considering some one soil element, because all this all are soil. So now we are considering soil element E, which is subjected to two kinds of pressures, na. So because we know that in any soil element there exist two kinds of pressure. First is vertical, second is horizontal. Okay, so this vertical pressure which is acting at depth z, because we are considering at the depth z. Okay, so this vertical pressure we can calculate as sigma v equal to gamma into z. Okay, so this vertical pressure. तर आपण काय केलं, एक सॉइल सॅम्पल घेतला, ही बॅकफिल आहे, पूर्ण काय आहे बॅकफिल आहे, त्याच्यामध्ये एक ई सॉइल सॅम्पल घेतला. तर आपल्याला माहिती आहे की कोणत्याही सॉइल सॅम्पलवर दोन प्रकारचे फोर्स ॲक्ट होतात, एक हॉरिझॉन्टल आणि एक व्हर्टिकल. तर व्हर्टिकल प्रेशर हा किती डेप्थवर ॲक्ट होते, झेड. व्हर्टिकल प्रेशर कसा कॅल्क्युलेट करतो आपण, गॅमा इंटू झेड, बरोबर ना. प्रेशर इक्वल टू गॅमा इंटू झेड, सिग्मा व्ही इक्वल टू गॅमा इंटू झेड. आणि आता आणि हॉरिझॉन्टल प्रेशर दॅट इज सिग्मा एच, तेच आपल्याला कॅल्क्युलेट करायचे. हॉरिझॉन्टल प्रेशर दॅट इज सिग्मा एच. ठीक आहे. आता ही जी फिगर दाखवली आहे, तर ह्या फिगरमध्ये बघा, ही जी स्ट्रेट लाईन आहे, स्ट्रेट लाईन म्हणजे काय, ही वॉल आहे, बघा लक्षात. ही वॉलमध्ये काय आहे, ही दाखवली की व्हेरिएशन्स ऑफ द प्रेशर. आता अर्थ प्रेशर ॲट रेस्ट, ही व्हेरिएशन ऑफ प्रेशर आहे. अर्थ प्रेशर ॲट रेस्ट म्हणजे तिथे मुवमेंटच झालेलं नाही. आता इथे काय आहे, ही जी लाईन आहे, ही एवढा प्रेशर आहे, हा झाला तुमचा ॲक्टिव्ह, कारण इकडं अवे फ्रॉम द बॅकफिल आहे, बघा खाल्लेलं आहे, अवे फ्रॉम बॅकफिल. अँड हिअर इज दिस कर्व इज फॉर टुवर्ड्स द बॅकफिल or into the backfill, towards the backfill or into the backfill. So this curve will show all these three kinds of pressure. So there is rest pressure, this is active, this is a passive. So now we are looking towards the earth pressure at rest. Now here we are calculating the vertical pressure, that is sigma v is gamma into z, and sigma h. Now we are looking towards the sigma h. Okay, so out of that, gamma is the unit weight of the soil. And if you consider the soil mass is or the backfill is homogeneous, then both sigma v and sigma h increased linearly with the depth z. So in the such case, ratio of sigma s to sigma v, which is called as a constant, that is called as a K0, that is coefficient of earth pressure. आत्ताच आपण पाहिलं ना, K0 means काय, coefficient of earth pressure, the ratio of horizontal pressure to the vertical pressure. It is denoted by letter K0. Okay, but sigma h हे आपल्याला अननोन आहे, आणि सिग्मा व्ही म्हणजेच काय आहे, गॅमा झेड आहे. ठीक आहे. सो मग आता सिग्मा एच इक्वल टू काय येईल, मग त्यानुसार इक्वल टू सिग्मा एच हाच जर फॉर्म्युला म्हणजे काय येईल, हे बघा, K0 इक्वल टू काय असतं, सिग्मा व्ही अपॉन सिग्मा एच अपॉन सिग्मा व्ही. सो मग आता K0 इक्वल टू काय येईल, मग आता सिग्मा एच अपॉन सिग्मा व्ही म्हणजे काय, गॅमा इंटू झेड. मग सिग्मा एच इक्वल टू किती येईल त्याच्यानुसार, K0 इंटू गॅमा झेड, बरोबर ना. हा दिस मल्टिप्लिकेशन. सो सिग्मा एच इज K0 इंटू गॅमा झेड. आता हे आपण हे कन्सेप्ट कुठपर्यंत घेतला, दिस कन्सेप्ट वी आर टेकिंग अप टू ओनली दिस हाईट, बरोबर ना. हा जो कन्सेप्ट आपण घेतला फक्त ह्या झेड हाईटपर्यंत. जर आपण एंटायर वॉल जर घेतली आपण कन्सिडर, तो सिग्मा एच इक्वल टू काय येईल, मग आता K0 इंटू गॅमा कॅपिटल एच, कारण आपण मागचे कन्सेप्ट कुठपर्यंत घेतला होता, हा अप टू दिस हाईट. सो फॉर होल हाईट फॉर्म्युला बिकम सिग्मा एच इक्वल टू K0 गॅमा एच. ओके, मग त्याचं डिस्ट्रीब्युशन ऑफ प्रेशर कसं होईल अलॉंग द हे डिस्ट्रीब्युशन ऑफ द प्रेशर बघा. सो ॲट द बेसला प्रेशर ओके, ॲट द बेस द प्रेशर विल बी K0 गॅमा एच. आता जर आपण ह्या हाईटला पाहिलं एच झेड हाईटला, इथं काय असेल K0 गॅमा झेड, बरोबर ना. ह्या बेसला किती आहे, कारण टोटल हाईट कन्सिडर केली ना आपण. ॲट द बेस टोटल हाईट बेसला किती आहे K0 गॅमा एच. आणि जर इथं ह्या लेवलला किती असेल K0 गॅमा झेड असेल. ठीक आहे. मग आता आपल्याला जर टोटल प्रेशर कॅल्क्युलेट करायचं असेल, आपण आता हा जो कॅल्क्युलेट केलेला आहे हा प्रेशर फक्त बेसलाच कॅल्क्युलेट केला आहे. ओके, सो दिस प्रेशर इज ॲट बेस ओनली. ओके, इफ यू वॉन्ट टू कॅल्क्युलेट टोटल प्रेशर acting out to the wall, okay, because this pressure is at base ला व्हॅल्यू किती याची K0 गॅमा एच. आणि जसं जसं आपण वर जाऊ तसं तसं सॉईलचा प्रेशर हा कमी होत असतो. तसं आपण पाण्याचा पाहतो बघा, सेम लाईक वॉटर. पाण्याचा प्रेशर जसं जसं खाली जाऊ तसं पाण्याचा प्रेशर जास्त असतो, जसं वर जाऊ तसं पाण्याचा प्रेशर कमी असतो. सेम लाईक दॅट ॲट द बॉटम द प्रेशर विल बी Ka गॅमा एच. जर आपण झेड थिकनेसला चेक करायचं असलं तर Ka इंटू गॅमा झेड. मग आपल्याला जर टोटल आपल्याला अर्थ प्रेशर ॲट रेस्ट काढायचं आहे आपल्याला, तर कसं काढणार आहे. प्रेशर म्हणजे काय असतं, प्रेशर काढायचं त्याच्यासाठी काय करावं लागेल आपल्याला, ह्या होल सेक्शनचा आपल्याला काय काढावं लागेल, एरिया काढावं लागेल. मग याचा एरिया काय येईल, ह्या ट्रायंगलचा बेसला व्हॅल्यू किती आहे Ka गॅमा एच आणि याची टोटल हाईट किती आहे एच. या ट्रायंगलचा एरिया काय असतो 1/2 बेस इंटू हाईट, दॅट इज 1/2 Ka गॅमा एच इंटू टोटल हाईट इज एच. ओके, सो मग फॉर्म्युला काय होईल तुमचा आता 1/2 Ka गॅमा एच, दॅट इज 1/2 Ka गॅमा एच इंटू एच, म्हणजेच काय येईल 1/2 Ka गॅमा एच स्क्वेअर. मग हा जो प्रेशर हा कुठं ॲक्ट होणार आहे, विच इज ॲक्टिंग ॲट द सेंट्रॉइड. मग ट्रायंगलचा CG कुठं असतो, बेसपासून असतो h/3 ला आणि टॉपपासून असतो 2h/3 ला. सो इट इज ॲक्टेड ॲट h/3 फ्रॉम बॉटम. ओके, मग आता आपण पाहूया, कळलं का कन्सेप्ट तुम्हाला. सो दिस टोटल प्रेशर ॲट रेस्ट कंडिशन इज 1/2 K0 गॅमा एच स्क्वेअर, बिकॉज K0 इज कोएफिशिएंट फॉर रेस्ट कंडिशन. K0 also obtained by basic elastic theory. ओके, द व्हॅल्यू ऑफ K0. आता आपण हेच फॉर्म्युला पण आता इलॅस्टिक थिअरीने एकदा चेक करूया. बाय बेसिक इलॅस्टिक थिअरी काय असते त्यानुसार आपण आता हे K0ची व्हॅल्यू काय आहे ते आपण पाहूया. सो इफ cylindrical sample of a soil is acted upon vertical stress, okay, vertical stress. So according to the elastic theory, आपण आता सॉममध्ये पाहिलं होतं बघ इलॅस्टिक थिअरी काय असते. बॉडी सब्जेक्टेड टू 3 म्युच्युअली परपॅन्डिक्युलर स्ट्रेसेस, दॅट इज सिग्मा एक्स, बरोबर ना. हा असतो सिग्मा वाय अँड थर्ड वन इज सिग्मा झेड. ओके, दॅट इज यूनिॲक्सियल स्ट्रेस सिस्टम, बायॲक्सियल स्ट्रेस सिस्टम अँड ट्रायॲक्सियल स्ट्रेस सिस्टम. सो हिअर वी आर कन्सिडरिंग ओनली फॉर द बायॲक्सियल स्ट्रेस सिस्टम. फॉर्म्युला फॉर लॅटरल स्ट्रेन आपण त्यात पाहिलं होतं. फॉर्म्युला फॉर द लॅटरल स्ट्रेन विल बी 1/E इंटू ब्रॅकेट सिग्मा एच मायनस म्यू सिग्मा एच प्लस सिग्मा ए. आता हा फॉर्म्युला आला कुठून, हा फॉर्म्युला आला स्ट्रेंथ ऑफ मटेरियलमधून. फॉर बायॲक्सियल स्ट्रेस सिस्टीम, फॉर द बायॲक्सियल स्ट्रेस सिस्टीम फॉर्म्युला हा फॉर्म्युला फॉर बायॲक्सियल स्ट्रेस सिस्टीम, दॅट इज 1/E. किंवा तो फॉर्म्युला असा असतो तुमचा की एक्स ट्रेन इन एक्स डायरेक्शन, ट्रेन इन वाय डायरेक्शन, दॅट इज EX/E इक्वल टू सिग्मा एक्स बाय E मायनस म्यू सिग्मा Y/E. आता आपण ते स्ट्रेंथ ऑफ मटेरियलमध्ये जाणार नाही. तर किंवा असं कन्सिडर करा की 2 डायरेक्शनचे स्ट्रेस येते. एक स्ट्रेस आहे सिग्मा एच ए आणि दुसरा आहे सिग्मा फी ए. तो फॉर्म्युला काय असतो तुमचा, दॅट इज स्ट्रेन इन वन डायरेक्शन इक्वल टू दॅट इज सिग्मा एच बाय E मायनस म्यू सिग्मा Y/E विल बी द युअर फॉर्म्युला. सो त्यानुसार हा फॉर्म्युला तयार झाला आहे 1/E मायनस सिग्मा एच मायनस म्यू सिग्मा एच प्लस सिग्मा व्ही. तर E म्हणजे काय असतं, मॉड्युलस ऑफ इलास्टिटी और यंग्स मॉड्युलस. म्यू इज युअर पॉयझन्स रेशो, पॉयझन रेशो. that is the ratio of lateral strain to the linear strain, that is called as the Poisson's ratio, and modulus of velocity is the ratio of stress to the strain, that is capital E. बट आता आपण काय सांगितलं की रेस्ट कंडिशन असल्यामुळं काय की वॉलची मुवमेंट होत नाही, बरोबर. देर इज नो मुवमेंट इन अ वॉल मीन्स द स्ट्रेन मुवमेंटच होत नाही म्हणजे स्ट्रेन होणार नाही. स्ट्रेन म्हणजे काय असते की दॅट इज कॉल्ड ॲज अ मुवमेंट ऑर कॉल्ड ॲज अ डिफॉर्मेशन ऑर द डिस्प्लेसमेंट or to the change. There is no any change in due to application of the load. There is no any changes occur into the wall is kept at their original position, means there is no strain occur into wall, means the lateral strain, that is E equal to 0. So value of E equal to 0. Okay, so it's so for this condition मग आता काय केलं E equal to व्हॅल्यू काय घेतली आपण स्मॉल e, that is epsilon E म्हणू शकतो मी. सो मग आपण हा जर फॉर्म्युला काय येईल मग आता 1/E into bracket sigma h minus mu sigma h plus sigma v is equal to 0, because E is equal to 0, or we can also call as sigma h by sigma v by solving equal to mu upon 1 minus mu upon 1 minus mu, or we can also call as sigma h equal to mu upon 1 minus mu into sigma v. हेच आपण सॉल्व केले ना, into sigma v. Okay, that is equal to k0 into sigma v, or sigma v म्हणजेच काय असते k0 into gamma z. आता हे k0 ची व्हॅल्यू काय असणार तुमची, k0 इज नथिंग बट म्यू अपॉन 1 मायनस म्यू, कारण आपण इथे म्यू आपली व्हॅल्यू काय आली म्यू अपॉन 1 मायनस म्यू, त्यालाच आपण काय म्हणले आपण k0, त्यालाच म्हणलं आपण k0. वी कॅन टेक ॲज इट्स व्हॅल्यू ॲज k0, आणि सिग्मा v म्हणजे काय असते गॅमा झेड. सिग्मा v म्हणजे गॅमा झेड. हे फॉर्म्युला झाला आपला k0 into gamma z. But according to Jackie, value of k0 in given equation आपण घेत असतो k0 equal to 1 minus sin of phi. We can take as value of k0 equal to 1 minus sin of phi. हां, आता आपण मागच्या केसमध्ये पाहिलं होतं की कोइफिशियंट ऑफ ॲक्टिव्ह अर्थ प्रेशरचा फॉर्म्युला असतो 1 minus sin of phi upon 1 plus sin of phi. कोइफिशियंट ऑफ पॅसिव्ह अर्थ प्रेशर, that is kp, that is 1 plus sin of phi upon 1 minus sin of phi. So coefficient of active earth pressure at rest formula only k0 equal to 1 minus sin phi, only 1 minus sin of phi. So phi is the angle of internal friction. So from that we can solve a simple problem. It may be asked for your 2 marks for your online examination. Okay, if the retaining wall is of 5 meter height, the retaining wall is of 5 meter height, is restrained from yielding, what will be the rest pressure per meter length of the wall. Okay, so in the given data, so backfill is cohesionless. Cohesionless soil म्हणजे काय असते, that is a sandy soil having phi equal to 30 degree and gamma equal to 80 kilonewton per meter cube, and also determine resultant force. Okay, resultant force काय आहे तो कॅल्क्युलेट करा. So आता माहिती आहे आपल्याला k0 फॉर्म्युला काय आहे, k0 मीन्स 1 minus sin of phi, that is 1 minus sin of 30. हे झाला आपला k0, that is coefficient of earth pressure at rest, and now we have to calculate what is the resultant force. The resultant force, that is we know the formula, that is total earth pressure formula काय आहे 1/2 k0 gamma s square, that is 1/2 k0 is 0.5 into gamma is 18 into h, total height is 5. So that is 1/2 into 0.5 into 18 into pi square, that is 112.5 kilonewton per meter length of the wall. Okay. So next is next we are discussing about the earth pressure theories. Earth pressure theories means the theories was developed to calculate the values of total active earth pressure and passive earth pressure as well as earth pressure at the rest. The various scientists were developed their own formulas for various backfill conditions. So according to last 17 centuries, the first scientist, the name of first scientist is called as the Rankine's theory. So he is not considering effect of the wall friction, and second is called as the Coulomb's theory. Okay, these both theories are the classical earth pressure theories. So beyond that there are further new scientists, that is theory of Kalman's theory, and then the Rabin's theory, and all other theories. But these two theories, that is Rankine's theory and Coulomb's theory for earth pressure, are called as the classical lateral earth pressure theories. Okay, so in this both the theories, it is required that soil mass, or at least certain part of soil mass, is in state of plastic equilibrium. Plastic equilibrium means this equilibrium, plastic equilibrium means we had already discussed what is plastic equilibrium and elastic equilibrium. So here we are considering what is the plastic equilibrium and what is the elastic equilibrium. Plastic equilibrium means when the soil mass is very close to the failure, okay, very near to the failure, or the soil mass is in at the stage of verge of the failure, that is very close to the failure, that which is satisfied by the Mohr-Coulomb law. Okay, that is called as a plastic equilibrium. म्हणजे सॉइल मास मध्ये काय होते की फेल्युअर होते, फेल्युअरच्या एकदम जवळपास गेलेले, दॅट इज कॉल्ड ॲज अ verge of the failure, state of verge of failure, that is called as a म्हणजेच elastic equilibrium म्हणजे काय असतं, in this test every point in a soil mass is not verge of a failure. Verge of failure means is not very close to the failure, every point. So in a plastic stage, every point in a soil mass is very close to failure, very close to the failure. Every point in the soil mass is very close to the failure. Okay. So now we are discussing the first theory, that is Rankine's theory. Okay, Rankine's theory. And what are the various assumptions made in the Rankine's theory? So the Rankine was the first engineer who used the concept of the plastic equilibrium. Note that the concept of the plastic equilibrium more rational to tackle the stability problems. He made some assumptions that are follows. Okay, so first of all, the soil mass is homogeneous and isotropic. We know that what I mean by so homogeneous means all the properties are same, and isotropic means all the properties are same in respect to direction. When the soil mass is cohesionless, soil is cohesionless. So here he is considering only cohesionless soil, that is sandy soil. He is not taking cohesive soil and dry soil. And the backfill is dry, and as well as the backfill surface may be horizontal or inclined. Okay, so what is meant by the backfill? So this is a retaining wall, and this is called as a backfill. The material placed back of the wall, so it may be backfill wall may be horizontal or it may be inclined. Okay, this is backfill may be horizontal or it may be inclined, and if the surface which is contact with the back of the wall will be smooth. So this is a surface which is contact with the back of wall will be smooth, means there is no friction will be occur in between wall and the soil. Okay, which is in contact, and this soil sample which is having dry soil, so backfill soil is dry, then so this lateral pressure is limited to vertical walls. Okay, so this pressure, lateral pressure which is acting, which is limited only for vertical walls. It is not acting on any other part. It is not concerned with the, that is toe or heel portion of the wall. It is limited only for the vertical wall, and it varies linearly with the depth. Okay, it varies linearly with the depth means if we plot the resultant stress distribution diagram, so it varies with the depth. So at the top its value is 0, and if you are going below the at the depth its value goes on changing, and at the base its value is Ka gamma h. Means at the top there is a 0 value, and at the base value is Ka gamma h. It means that its value goes on increasing from towards the depth from or its value is decreasing from bottom to top, and top its value is 0, and resultant force which is parallel to the backfill surface. Okay, so resultant force is parallel to the backfill surface. So in the sloping backfill, sometimes we have to assume we have to shifted resolve the force into two mutually direction. One is x direction, one is y direction. So at that time we have to calculate one resultant force also. So this resultant force is parallel to the backfill surface. And last one, that is walls yields wall will yield about base sufficiently for active earth pressure condition to develop its passive case. That under consideration, the wall is taken to be pushed sufficiently towards the field for passive resistance to be fully mobilized. So in active condition, the wall will be shifted from from the back pill, and for passive condition, wall will be move or push into the soil. Okay. So the next is the Rankine states plastic states of equilibrium. So there are two cases, as we know that. First is the Rankine active state of plastic equilibrium, second Rankine passive state of plastic equilibrium. Okay. So in that, so these are the equilibrium condition. So this so first case. So in the what will happen in the first case? So let us consider in the passive zone. In the passive zone, what will happen? The wall will move towards the back pill. So this is the back pill. Wall move towards the back pill. This is wedges, or this is the failure surface. This is the front of the wall. This is the back of the wall. Okay, this is the front of the wall. Okay, so this is the original position. Back line will show the original position of wall, and in the passive zone, wall move towards the back pill. Okay, so this dotted line will show that in the initial condition it is at black position, original position, and at the end condition it is moved towards the back of wall, and we see that there is a large amount of area will be covered by this passive condition. There is large amount of expansion that is due to this passive condition, or we can say the large amount of deformation. This deformation which is called as positive deformation. So while in the case of the active earth pressure, due to this active earth pressure, wall move away from the back pill. Okay, so original position of the wall is just like that. This black color shows the original position. Due to application of this earth pressure, the wall will be shifted. Okay, so this line will show us the shifting of the wall. This is shifting of the wall. Okay, and this is a failure surface. So we show that the very small amount of failure surface as compared to the passive earth pressure. And if you plot this failure zone, it will be the 45 plus 5 by 2, 45 minus 5 by 2. These are the failure zones, or angle of failure zone, that is 45 minus 5 by 2, and here is 45 plus 5 by 2. So phi is called as the angle of shearing resistance. Okay, so we see one by one. So first one, that is Rankine's active plastic state of equilibrium. So in that, when movement of wall which left causes cohesionless soil expands and horizontal stress goes on decreasing to reach critical stress condition. Okay, as we know, the movement of wall towards the left. So this is wall, and towards the left causes cohesionless soil. Why cohesionless soil? Because this condition, as our assumption is cohesionless soil. We are Rankine using this theory for cohesionless soil, due to which what will happen, there is expansion of the soil, and these horizontal stresses, that is stress which is goes on decreasing to reach critical stress condition. And when we plot the stress circle, this stress circle touch while touching it gives a more strength. So this strength envelope is in on verge of failure. Okay, if you see this active earth pressure, okay, this is the movement of wall. Okay, this is the expansion surface. Okay, this is a slip surface, and if you show that this is a Mohr circle. This is a Mohr circle. It is having a value of 45 plus theta by 2. This is 45 plus theta by 2. This is the vertical stress gamma h into z, and this is Mohr circle. Okay, and why this is this equation, this is called as a strength envelope, because why this equation is not like that tau equal to c plus sigma tan phi, it is only write as sigma f plus tan phi, because this theory is applicable for cohesionless soil. Okay, so here value of c is taken as 0. Okay, So here his value is 45 plus theta by 2. So here what will happen? So when we plot the more stress circle and it touches and if we plot the envelope, it touch when it is touch the strength. When we plot the strength envelope, it touch the Mohr circle. Okay, it touch the Mohr circle at the value sigma f plus tan of phi. So this condition is called as the Rankine's active state of plastic equilibrium. It generally in this what will happen, expansion from the negative formation which is called as active state. इसमें क्या होता है, that is negative expansion. So backfill expansion will show. So next this is passive case. So it is a reverse case in which there is a movement towards right causes composition of soil towards right, that is causes cohesionless soil to move towards the right. So this horizontal stresses which is goes on increasing. So in the previous case horizontal stresses which is goes on decreasing at a constant stress and finally reaches to the critical stress condition. Okay. So in the active state the horizontal stresses goes on decreasing, and in the passive state horizontal stress which is goes on increasing. And if we plot the Mohr stress circle, this circle will become extra large, and if we plot we join with the strength envelope, okay, it is at the stage of verge of the failure. Okay, this is called as a Rankine's passive state of a plastic equilibrium, and it will show the positive deformation. Okay, so this is a backfill compression. So in the active state there is a backfill expansion. So here is a backfill compression. So here is a compression of the soil, and in the active state there is a expansion of the soil. Okay, so this is a expansion. This graph shows the expansion in active stage because wall move away from the backfill, and this will show compression, that is wall move towards the backfill. And if we plot the Mohr circle, so this Mohr stress circle is become extra large as compared to the active earth pressure condition. And this if you join this if you plot this strength envelope, it will show the value that is sigma tan of phi. Okay, it is but it is having value that is 45 minus pi by 2. So in the previous case its value is 45 plus pi by 2. Okay, so here its value is 45 plus pi by 2. This angle is having 45 plus pi by 2. So this, okay, so this is case on active and this is case for passive. Its value is 45 plus pi by 2, and here its value is 45 minus pi by 2. Okay, because the value of phi is less as compared to 45 degree, and here is the value of phi is greater as compared to 45 degree. Okay, so these are the Mohr stress circles for the plastic equilibrium. Okay, so you can take a screenshot of this all these parameters. So I will tell you so what is meant by all the parameters. So this I is called as I is the first Mohr circle. This is I is called as the first Mohr circle, that is Mohr circle for pressure at rest condition. Then okay, then the A, that is capital A, this is capital A, this is the Mohr stress circle for active earth pressure condition. Okay, because we see in last case we see that the active earth condition, the stress circle is very small as compared to the passive earth pressure condition. So this is the first circle is for rest condition, this second circle is for active condition, and this B, that is Mohr circle for passive earth pressure condition. Okay, so then this sigma 3, this is value, this sigma 3 which is called as a minor principal stress, and here is a minor principal stress. So here is a minor principal stress sigma 3, and here to here, that is called as a sigma 1, that is a major principal stress. Here is a minor principal stress. Okay, then the K0, so here is some value is K0. K0 means the coefficient of active earth pressure at rest. Then the Ka, so Ka stands for coefficient of active earth pressure for coefficient of active earth pressure. K0 means coefficient of earth pressure at rest, A means coefficient of active earth pressure, Kp means coefficient of passive earth pressure. Okay. Okay, so this is a Mohr column failure line, this is a Mohr column failure line, which is called a strength envelope. So this is the pole of active earth state, this is the pole of passive earth state. Then its value, note that for active that is 45 plus theta by 2. So note that this value is important, it is 45 plus theta by 2 for active, and for passive 45 minus theta by 2. Okay, these are the very important. And what is meant by sigma 1, that is the major principal stress, and sigma 3 is the minor principal stress. That is sigma 1 is nothing but that is our sigma v, that is vertical stress, and sigma 3 that is the minor principal stress, that is sigma h. Okay, we know that there are two stresses, that is vertical and one is horizontal. So sigma v is considered, we can consider as sigma 1 v as sigma 1, and sigma h that is vertical stress, that is horizontal stress, that is sigma h. So this sigma v, this is minor sigma 1, that is major principal stress, that is value, that is sigma v, and sigma h, this is sigma 3, and this is sigma 1, that is my major principal stress, and sigma 3 that is minor principal stress. Okay. So these are the cases. This is the rest condition, this graph shows the rest condition, passive condition, active condition. Okay, this is the mode of the failure, this is graph shows, this is the active, the passive, this is expansion, sorry, contraction zone, expansion zone, and in the rest condition there is no any kind of strain is happen, that's why there is no any graph is shown over here. Okay, so in the next lecture we will